Peggy invests $10,000 when her grandchild is born for the child's college education. She records the value of the investment in a table according to the annual statement she receives from the investment firm. Use successive ratios to generate a function model. Then use the function model to predict the worth of Peggy's investment after 18 years when her grandchild is ready to enroll in college. Determine the reasonableness of her prediction. Okay, let's first point out our quantities here. So we've got the time since the grandchild's birth and the worth of the investment. And so the time would be our independent variable. Let's just call that t for time. And that just goes up, notice, just goes up by 1 every single time. So our delta t is 1. And then for the worth of the investment, that would be our dependent variable since that's dependent on the time it's in the actual account. And so let's just call that w of t for worth. And so now let's find the successive ratios. And so to do that, then we just need to take the WT value of the greater t value and divide it by the W of t value of the lesser t value. So we'll take 10,304 and 16 cents and divide it by 10,000. And so doing that, then we get 1.030416. And then dividing the next two, again from right to left there, then we get a very similar number, except for that after 1 it's 5.8. Well, if we round that off to that 6th decimal place again, then we get the exact same number as the first ratio. And then doing the next two, these also divide to this exact same number when we round to that 6th decimal place. And so now we can write out our function. So WT equals the beginning values, and so when t is 0, then WT is 10,000. And so our initial value will go there in front, and then times our ratio, which we have the same on each one, and then raised to the t, because our delta t is just 1, so we'll just be raising that to the t. And so using that, then we can predict for 18 years how much money will be in that account. And so all we need to do is just plug in 18 for t, since t is our time in years. So plugging in 18, so plugging that in, then we get 17,148 and 52 hundredths if we round it off, because it's going to be in dollars and cents. And so that's the predicted value. So to see if this is reasonable, we can use the rule of 72. And so the rule of 72 just says that the initial value, so 10,000, that will double to 20,000 in the amount of years of 72 divided by the interest rate. And so just note here that our ratio as a percent would be about 103%. And that just means it's taking what it had the year before and it's adding another 3% to it. And so our interest rate here, that means it's about 3%. And so then we take 72 divided by 3, and that gives us 24. And so this model says that in 24 years, we should double our value. And so using that to estimate, then, 17,000, that's pretty close to 20,000, but it is lower, which it should be since that's only 18 years. And then it's much higher than 11,273 and 28 cents, which was the value of 4 years. And so it does make sense with the range of numbers that we have. And so we can go ahead and summarize our answer. Let T represent the time in years since Peggy's grandchild was born, and WT represent the worth of Peggy's investment. Using successive ratios, W of t equals 10,000 times 1.030416 to the t, which means that the interest rate is about 3%. The modeling function predicts that Peggy's investment will be worth $17,148.52 when the child is 18 years old. Using the rule of 72, which states that an investment doubles in value every 72 divided by the interest rate as percent years, the investment would be worth $20,000, approximately 72 divided by 3 equals 24 years after the initial principal investment. The investment having a value between $11,273.28 and $20,000, but closer to $20,000 after 18 years, is a reasonable prediction.